I'm here at my local fire department with veteran firefighter Dick Sathers. Dick, we electrical nerds have a fun little saying. What do you call a wire that's too short and too thin?
Too short and too thin. I have no clue.
A fuse.
Oh boy. Oh no.
In all serious note, the way this works is as we try to send too much amperage through a wire, it heats up and we dissipate that power as heat. In the case of a fuse, it melts the wire and breaks the circuit. Firefighter Sathers is going to help us demonstrate this effect using an infrared camera in just a moment. And every year around the holiday season, fires are caused because of improper wiring, and we run the risk of damaging our equipment, or worse, when we do the same. Dick, how many years have you been a firefighter?
38 years with the city of Bemidji.
Outstanding. And how common in those 38 years are electrical fires? It would seem that, with the advances in technology, maybe it's getting better or not really. We still have to be careful.
I would say it's getting better, but it's definitely a good cause of fires with the Bemidji Fire Department. Smoking being number one, and probably electrical. I think we'd be safe to say that might be number two.
No kidding, number two. Wow. What steps should we take to avoid those electrical fires?
Certainly, whatever appliance you're using, you've got the correct cord for it and the correct outlet or circuit with the right amount of amperage for whatever you're using. That's very important for people to take the time to understand that and realize what they should have.
Thank you, Dick. If we should encounter an electrical fire, hopefully we're not the cause of it, but if we should be, what steps should we take?
Okay. In the fire department, we always say, get out and stay out. It all depends on what stage this situation is at. Is it just a smell? One of the most common things with electrical fires is a smell that develops, and that's from the burning insulation or the overheated insulation or electrical cords. You smell something. If that's the case, probably the best thing you can do is go to your electric box and kill the main breaker.
Remove the power source.
Remove the power source, yes, because that way, it should stop whatever is overheating. If it's gone beyond that and you see smoke or something along that line, then yeah, we want you to get out of the house. We want you to be safe, so get out and stay out. And maybe you can even secure the power from the outside, more than likely not, but if you can, then that's a plus.
Sure, and if it's a venue we're working in on our way out, we should probably hit the fire alarm and make sure everybody else has a chance to get out.
Yeah, especially, commercial business, hit the fire alarm, make sure everybody gets out. Yeah, absolutely.
Awesome. Compare the heat of this 16 gauge cord carrying the exact same load as this 12 gauge cord. After running those tests, firefighter Sathers introduced me to a new member of the Bemidji Fire Department, and I'm going to get his take on it. So, Peter Humanick?
Yep.
How long have you been at the Bemidji Fire Department?
I've been on the Bemidji Fire Department for about a month now.
About a month, so you're fairly new to the works, but obviously you went through training and a lot of things they taught you there.
Yep.
Give me your kind of reactions to watching those two cords and how much hotter the 16 gauge cord got.
Yeah, it's amazing how hot that cord actually got, and it's surprising. I think a lot of people don't realize how much of a fire hazard it can be.
Yeah, these are commercial grade UL listed extension cords, and we had them on a cool concrete slab. But if that was maybe under a table on a carpet or in a ballroom or a banquet facility or something, I mean, that maybe poses a real threat. You think?
Yeah, it's definitely a fire hazard, and like I said, a lot of people don't realize it. It's Christmas and everyone's hooking up their lights and having a good time, and you forget to check the safety, and like the next thing you know, your house is on fire, and it's never a good thing.
Yeah, no, absolutely, and especially important for those of us who are working in commercial venues, or we're out entertaining. We've got large groups of people in a building. Obviously a house fire is a tragedy, but as professionals, we're called upon to a higher standard, and we need to be accountable for that. We were approaching the boiling point of water, I think, with that cable at the point when we unplugged it, and all we saw was it just continued to go up and up. So I guess who knows how far it would go. But appreciate your reaction to it. We'll certainly do our best to keep all the geeks out there in TV land safe. So,
all right,
thank you, Firefighter Humanick.
Yeah, thank you, pleasure.
Dick, on behalf of myself and all the geeks out there in TV land, many thanks to you and your comrades for running into a building when the rest of us run out. Greatly thank you for your service.
Absolutely. I'm glad to do it.
To help you avoid the same trouble with volt drop and fire danger, we've put together this chart to help you determine what gauge extension cord you should use, given a known length and amperage. Now, all voltages are assumed to be the US standard of 120 volts. Similarly, we can lose valuable output from our amplifier and cable. Taking that 3 dB loss means losing half of the power produced by an amplifier, and I can't consider that to be an acceptable loss. Now, what's acceptable is up to you, but I want to limit my losses to a 0.5 dB max. The trick is that this loss will be relative to the impedance of the loudspeaker. The amplifier's power will be used proportionally by the loudspeaker and the cable. If we have a 1 ohm loss in our cable, that's 12% of an 8 ohm load, but it's 25% of a 4 ohm load. Therefore, if a 12 gauge cable is a 0.5 dB loss at 150 feet with an 8 ohm load, it only takes 75 feet of cable to lose that same 0.5 dB with a 4 ohm speaker.